What if you died in space? Dying in space. It's the kind of scenario most of us encounter in the realms of science fiction, dramatic movie scenes, or the dark corners of our imagination late at night. Yet, as humanity continues its journey beyond Earth's atmosphere, building space stations, launching deep space probes, and even planning missions to Mars, the question becomes less theological and abstract. What really happens if you die in space? What would your final moments be like? What happens to your body afterward? And, perhaps most hauntingly, what would your death mean for those you left behind, and for the larger human endeavor in exploring the cosmos? To begin unraveling this unsettling yet fascinating topic, let's imagine you're an astronaut, far from home, orbiting hundreds or thousands of kilometers above Earth. Maybe you're aboard the International Space Station, on a lunar base, or one day, circling the red sands of Mars. Suddenly, something goes wrong. A medical emergency, a catastrophic accident, or equipment failure that leads to the end of your life. The story of what happens next is determined by science, physics, technology, and our still developing understanding of life and death beyond the shelter of our blue planet. Let's start with the most immediate and visceral question. What do those final seconds feel like in the cold void of space? If you die inside a spacecraft, within a pressurized module, that death isn't all that different, from a physiological perspective, from dying on Earth. The air is breathable, gravity is merely altered by microgravity conditions, and you'd likely die from familiar causes: cardiac arrest, stroke, trauma, or disease. Medical assistance would be performed by your fellow crew, perhaps guided by mission control, though medical facilities are limited and ill-equipped to handle severe crises. But perhaps more harrowing is the scenario that occupies so many nightmares: dying outside the spacecraft, in open space, with nothing between you and the interstellar void but the thin shell of your spacesuit. What would it feel like to be exposed to raw space? What would your last sensory impressions be? Contrary to some depictions in film, your body wouldn't instantaneously freeze solid, nor would you implode. The outer layers of your body would experience the vacuum first. Air in your lungs would rush out if you failed to exhale, risking rupture of the delicate alveoli. Blood and bodily fluids, no longer held down by atmospheric pressure, would form gas bubbles and begin to boil, not in the fiery sense, but as a result of lowered pressure allowing dissolved gases to escape. You'd lose consciousness within 15 seconds as oxygen in your bloodstream depleted rapidly. Before you're even aware of it, you'd likely black out. A silver flash, a sense of overwhelming disorientation, and then darkness. After loss of consciousness comes hypoxia, cellular suffocation. There is no air to breathe, no oxygen to take in. Surprisingly, you wouldn't freeze straight away either. In the vacuum of space, heat leaves your body only through radiation, a slow process. The water in your body's outer tissues might begin to vaporize, swelling your skin, but not causing you to explode. Eventually, you would perish from asphyxiation before the cold could kill you. If your death occurred inside a spacesuit, sealed, pressurized, but with a life support failure, your suit would become a tiny coffin, preserving your body from the vacuum. The temperature could plunge, depending on your distance from the sun and your orbit. Space isn't a uniform environment. In direct sunlight, temperatures can soar, while in the shade, they drop to hundreds of degrees below zero. Now, with the journey from life to death complete, a more enduring question arises: what happens to your body? On Earth, gravity and environmental forces collaborate to break down remains. Decomposition proceeds thanks to bacteria, insects, and other detritivores. But in the sterile, oxygenless, microbe-free environment of space, the normal processes of decay are arrested. If your body remains inside your suit or a craft, shielded from cosmic radiation, you could persist for years, perhaps even centuries. Skin might dry out, turning leathery, a process akin to mummification or freeze-drying, as moisture sublimates away. Internal bacteria may begin to consume your organs for a time, but without oxygen and with the subarctic cold, their activity would eventually cease. If your body is directly exposed to space, If your suit is breached, for example, the process is even more extreme. Within moments, your bodily fluids would begin to vaporize. Solar and cosmic radiation bombard your remains, breaking down cellular structures. In shadow, you may freeze solid, missed forever by sunlight. In sunlight, ultraviolet rays and cosmic rays would slowly desiccate and degrade your tissues, ultimately leaving little more than freeze-dried fragments. Lacking scavengers, bacteria, or environmental forces like wind or water, your remains could, in theory, drift undisturbed for millennia, orbiting silently amid the debris and satellites that circle the planets. Of course, protocols aboard spacecraft and space stations anticipate the possibility of death, though no astronaut has yet died in space itself. Space agencies like NASA, Roscosmos, and ESA all have evolved practical strategies for responding to a death in microgravity. These plans often involve storing the body in a cool, secure environment, a dedicated body bag or cold locker, until it can be returned safely to Earth for burial or cremation. On longer missions to Mars, or in the case of extended missions, returning home may be impossible for months or years. Here, the questions become more complicated. Would you store the body in a separate airlock, vent it into space, or attempt to preserve it until burial on another planet? Human remains, after all, must be managed with care to avoid health hazards and, as importantly, out of respect for the departed. On missions where burial on another planet is possible, say during a hypothetical Mars settlement, protocols must be even more detailed. Would we bury a body in Martian soil? How would the unfamiliar microbial ecology interact with an Earth body? NASA and other agencies are working to develop guidelines, balancing the risk of contaminating another world with terrestrial organic matter against the psychological and ethical need for closure. The death of an astronaut would have ramifications far beyond operational protocol. The impact on the crew, psychologically, emotionally, and practically, cannot be overstated. Astronauts train for years to handle emergencies, but the loss of a crew member in the confines of a small spacecraft or lunar base would be traumatic. It could threaten team cohesion and mental health. Grief might be compounded by isolation and the impossibility of traditional ceremonies or rituals. Astronauts are resilient by design, trained to compartmentalize and focus on mission objectives, but losing a friend and colleague on another world would be a profound test. And then there is the public. News of a death in space would ripple through society, evoking everything from shock and sadness to philosophical reflection. Our species invests astronauts with heroic mystique, explorers at the edge of the possible. The loss of one in the depths of space would be a sobering reminder of our vulnerability, even as we chase dreams among the stars. The prospect of death in space also inspires existential and spiritual questions, touching on the meaning of mortality, legacy, and our relationship with the universe. For thousands of years, every human who has lived and died has done so under the dome of Earth's sky, their remains returning to the cycles of life on the planet. What does it mean for a human to perish among the stars? Is it the ultimate gesture of our species' reach, a testament to human bravery and curiosity? Or does it represent a new kind of solitude, the ultimate exile? As space travel becomes more commonplace, these questions will only grow more urgent. Commercial spaceflight is on the horizon. Lunar colonies and crewed Mars missions are in sight. It is nearly inevitable that, sooner or later, someone will die beyond our planet. The way we respond, practically, scientifically, philosophically, will speak volumes about us as a civilization. Will we treat those moments and those people with respect and gravity? Will we learn to manage space deaths as calmly as we do hard landings and missed orbits, ritualizing and integrating loss into our culture of exploration? At the intersection of biology and physics, ethics and aspiration, the question of death in space asks us to confront the most essential questions about life itself. The mechanics, the how of dying in space, are in some ways the least mysterious. The science is stark and at times brutal. But the why, the purpose and the meaning carried by that journey, remains for us to define. If you were to die in space, Your body would become something rare and precious, a relic of humanity, a memorial to our audacity and our vulnerability. Perhaps, one day, drifting silently in orbit, or resting beneath alien soil on a distant planet, you would serve as a kind of ambassador for all those who reach upward. A sign not only of what awaits anyone who dares, but of the enduring spirit that compels us always to explore, even when the stakes include the ultimate price. Consider, too, the scientific legacy. The preservation of a body in space, naturally freeze-dried, mummified, or irradiated beyond recognition, provides unique research opportunities. What happens to the human body under long-term cosmic exposure? How does radiation alter tissues? Could we learn, through the study of such remains, more about the risks that await future astronauts and develop better safeguards? There is also the question of cultural memory. As with the graves of lost explorers on wind-blown poles or mountain crags, the remains of those lost in space might become sacred sites for future generations. Their stories would inspire, cherish, and haunt those who follow in their footsteps, both a warning and a call to bravery. Imagine future spacefarers, traveling to Mars or Jupiter's moons, passing by the orbiting remains of an earlier pioneer, dusty, silent, alone, yet, in a sense, immortalized by their celestial tomb. Would they visit and pay respects? Would a body remain, turning endlessly, a monument in vacuum? Finally, the scenario compels us to think about the limits of physiology. What does space demand of the human body in death, just as it does in life? Space is a profoundly inhospitable place, and even in death, the human body must contend with its extremes. Our remains do not decay as they do on Earth. Instead, they become artifacts, shaped by pressure, temperature, and radiation, suspended between the worlds we come from and those we yearn to reach. For most of human history, death has been a terrestrial event, rooted to soil and stone. In the coming era, we must accept that it will be a cosmic one as well. Each future death beyond Earth will write a new chapter in our story, a story shaped by courage, curiosity, and the unbreakable bond between life and the universe that cradles it. So, if you died in space, your ending would be more than a biological event. It would be an extract from the evolving narrative of humanity's place in the cosmos, a tale of frailty and determination, of risk and sacrifice, told on a canvas infinitely vaster than the world we've always called home. Your last breath may have been lost to the void, but your memory, and your very self, would remain part of the fabric of the universe, echoing in every future journey made by dreamers, explorers, and seekers who refuse to accept that the world ends at the edge of the sky.